Alright, so the next section is solving quadratic equations by factoring. So it basically gives you a reason why you need to know how to factor. Up until now, the only equations you ever got were something like this. Oopsie, you can't see that, can you? 3x plus 2 equals 11, right? That's what you saw in Math 112. That's what you saw in algebra. You subtract the 2, divide by 3, you have your answer. You never saw equations that had powers, like squares, all right? So that's what section 13.6 is all about. It's going to give you equations that look like this, that are more complicated, where they want you to find x. What makes that equation true, okay? So the first thing they say is a quadratic equation is one that can be written in the form ax squared plus bx plus c equals 0. So notice everything is what we saw before when we were using the AC method to factor. The new thing now is that we have an equal sign. Okay? We never had an equal sign before. They were called expressions before. Now we have an equal sign, which means we need to solve. If you can get this in standard form means everything to the left in this order and just 0 is on the right, then if we can factor it, we can solve. Why? Because of the zero factor theorem. And this is a theorem that says if A and B are real numbers, if A times B equals 0, then A or B equals 0. So basically they're just saying if you have two things that multiply to be 0, one or the other has to be 0, right? 0 knocks everything out. Like if I told you this, guys, 3 times x equals 0, what does 0 have to, or x have to be? 0, right? And that's the whole idea here. We have two unknowns, so either one could be 0. So that's what we want to do. We want to take our standard form of our quadratic equation, get it into those binomials that we're used to factoring, okay, and set each of those equal to 0, and we'll be able to solve, all right? So the steps say, write the equation in standard form so that one side of the equation is 0. So basically get everything to one side, equal to 0, have your x squared term in front, your bx term in the middle, and your constant in the back. If you can, then you need to actually factor and set each factor containing a variable equal to 0, solve those equations, and check your solutions, okay? So looking at this first one, notice everything's already to one side equal to 0, and it's already factored for us. This is a perfect example of A times B. This is a number times this number, okay? So let's figure out what x minus 3 equals 0 is and what x plus 1 equals 0 is. And these are linear equations, meaning they're only to the first power, so you know how to solve them, right? You're just going to move the constant over by doing the opposite operation. So x equals what? 3, or x equals negative 1. What you guys just did was you found the two x values that if you plug them into these equations, you'll get 0. Okay? Plug in 3, you'll get 3 minus 3 is 0, 3 plus 1 is 4, 0 times 4 is 0. He is a solution. Plug in negative 1, you get negative 1 minus 3 is negative 4, negative 1 plus 1 is 0, negative 4 times 0 is still 0. So what's different about these is that you actually can get two answers, and most of the times you will. Okay? Something to kind of keep in mind as you go through your mathematical career is the power of your highest exponent is typically how many solutions you have. So if we're dealing with quadratics where we have two powers, we usually have two answers, 95% of the time, okay? Look at this next one. This next one is already equal to 0, and it's already factored. It was just a GCF that they pulled out. They pulled out an x, so it's x times 5x minus 2. So since it's already factored, we can just set each of those factors equal to 0. So x is a factor, we'll set that equal to 0. And 5x minus 2 is a factor, so we'll set that equal to 0. And we'll solve each of those. Well, x equals 0, is there anything to solve there? No, that's already solved. So x equals 0 is a potential answer. 5x minus 2, we got to move the 2 over by adding it, right? And then what's our next step after you move the 2 over? How do you undo multiplication? Divide, right? So we're going to divide both sides by 5, and what do you get? 2/5. Does that look okay? And again, I plug them back in just to make sure they make work. If you plug 0 in here, you get 0. If you plug it in here, you get 0 minus 2, so you get negative 2. 0 times negative 2 is 0, so he works. 2/5, guys, will work as well. You'll have 2/5 here, but when you plug 2/5 here, that 5 up top will actually cancel with that 5 in the bottom and just leave you with a 2. So you'll have 2 minus 2. But what's 2 minus 2? 0. So you have 2/5 times 0. Guys, as long as you're solving these correctly, they're going to work, okay? So I know I'm checking them, but if you don't check them, it's not the end of the world. It's nice, though. The second you have an equal sign and you can check, it's kind of a nice solidification of, oh, I actually did it right. All right, so let's look at this guy. He's almost in the right form. Notice everything is over to the one side equal to 0. It's just not factored. But guess what we know to do? We know how to factor. That's what we learned the first week of school. So this is going to be the AC method. So our A is technically 1. Our C is negative 22. So our AC is negative 22. There's not a whole lot of room for you guys. Like, so if you want a separate piece of paper to do scratch work, what we have to think of is we have to think of factors, things that multiply to negative 22 but add up to negative 9. Well, 22 only splits up a couple ways, right? 1 and 22 and 2 and 11. Is there a way to use 2 and 11 to get to negative 9? There sure is. We're going to write this as x squared minus 11x plus 2x minus 22 equals 0. I'm going a little quick there because at this point, hopefully we're comfortable with the AC method. If we're not, just practice it on your own. You know, have your little chart on your scratch piece of paper. But does everybody agree that negative 11 times 2 gets you negative 22? But negative 11 plus 2 adds up to negative 9. Right? I just did the AC method there. Once you write it into groups by 4, remember you just do factor by grouping where we just look at 2 at a time. All right? Looking at x squared and then negative 11x, what can you factor out? An x. When you factor out that x, you should have x minus 11 remaining, correct? Over here we want x minus 11 remaining, so what do we need to factor out of 2x and 22? A 2 and a positive 2. So we're going to take out a positive 2. And I have x minus 11 remaining, and it equals 0. Woohoo! Because what do I have there? I have 2 ugly terms that have a GCF of what? X minus 11. So I'm going to factor out that x minus 11. And when I do that, are you guys left with x plus 2 as your remaining binomial? Does that look okay? What's crazy is we've done all this work and we still haven't gotten the solution. We've done all this work just to make it look like the first example we did, right? So remember, the whole idea is not to factor, but to factor so you can solve. And the whole idea is once you have it in factored form, you can just set each of those factors equal to 0 to solve, okay? So what are our 2 answers for x? 11 and what? Negative 2. Do you guys remember doing that in 112? Opposite operations, right? How do you get rid of that 11? You need to add it over to the other side. How do you get rid of that positive 2? You subtract it. And what's crazy, guys, is if you plug this in, you'll get the right answer. Can I show you on your calculator how you can do that? If I can do this without too much of a glare. So basically, wherever you see an x, you're putting in your thing, and you're going to square it and all that stuff. So we have an 11. So we're going to plug 11 in, and we're going to square it. Minus 9 times x, so minus 9 times 11, minus 22. Can you guys see that? So I'm just making it look like my initial quadratic, and the second I hit enter, what do I hope to get? The 0, and I do, okay? The only thing I want to warn you of is when you plug in negatives, make sure you put parentheses around it. So like, if I'm going to plug in my negative 2, I'm going to put parentheses around it like that, so it knows to square all of it, right? Minus 9 times negative 2 minus 22. When I hit enter, I have 0. So that's how you can always check your answers and make sure that you factored appropriately and all that fun stuff. All right, and so we're just going to kind of change up. Like actually every step of the way, guys, we're just going to make it a little bit more difficult. What's wrong with this is that not everything is to one side equal to 0. So what's the first move we need to make? We want everything to one side equal to 0. What's the first move we need to make on this one? Add the 49 over. When I add him over, he's the constant, so where does he need to go? In the back. So So this will be 4x squared minus 28x plus 49, because I added him over. Is that all right? Okay. Next thing is to look for a GCF. There's no GCF that you can take out of 4, 28, and 49. So we're going to use the AC method, where A is 4, C is 49, so 4 times 49 is 196. Oh, geez. I want to give you a little hint, and it doesn't always work, but do you notice that 4 and 49 are both perfect squares? Typically when you have two perfect squares, the square root of this is your answer. What's the square root of 196? Why can't I type today? What do you guys get? 14. What happens when you have 14 times 14? You get 196, but what's 14 plus 14? 28. So anytime your A's and C's are perfect squares, they multiply to be a perfect square, and usually that square root is your answer. How do I get a negative 28, though? What do I need to do to my 14s? Make them both negative, right? Because a negative 14 times a negative 14 is going to give you that positive 196, but the two negative 14s added together will give you the negative 28. So I'm going to write this as 4x squared minus 14x minus 14x plus 49 equals 0. And that's just a little trick. Could you still do 1 and 196, 2 and, what would that be? 88, you know, 3, and so you can, but it'd take you a while to get down to 14. So just notice if you have perfect squares kind of floating around, that most likely the answer is a perfect square. All right, looking at these first two terms, what can you take out of 4 and 14?
You could take out 4 and an x.
A 2 and an x, right? Because the 4 will come out of 14. So we'll do a 2 and an x. And remember, when you're factoring, you're just dividing. So what's 4 divided by 2? 2. What's 14 divided by 2? 7. Okay? On the back half, what do we notice about the signs? The signs are the opposite. We have a negative and a positive. We want a positive and a negative. So I'm going to take out a negative something. But what is it going to be that I take out?
7?
It is a 7, because I want a 2 left and a 7 left. So I'm going to take out a negative 7, and I'll be left with 2x minus 7. So do you guys notice it's basically what we did the second day of class, except for you have this equal 0 kind of tagging along with you. And we'll have that extra step at the end. So at this point, guys, whenever you have the matching 2x minus 7, you pull him out in front. But what do you notice you have left? 2x minus 7. That's called a perfect square trinomial, meaning the trinomial you started off with, 4x squared minus 20x plus 49, its two factors are exactly the same. So you can rewrite it as 2x minus 7 squared if you want. When it comes down to this, we need to set it equal to 0, but do we need to do it twice? No, you're going to get the same answer. So you're just going to take 2x minus 7 equal to 0 and just solve that once, okay? So you add the 7 over, you get 2x equals 7. Divide by 2, so you get x equals, what is that, 7 halves. And again, to check it, what you could do, I know this is kind of glary, to check it, we'll just punch in the left side, and when we hit equals, we hope it's a negative 49, right? So you do 4, and then in parentheses, 7 halves, so just 7 divided by 2 like that, squared, minus 28 times 7 halves. And when I hit equal, I hope it's a negative 49, and it is. So the left side equals the right side. So I always go back to the very original, because I could have done something right here in this step to mess it up. All right, this almost looks like it's already factored, but there's no 4, it's called a 0 product or factor theorem, which means this needs to be a 0, right? So we can't just take x and set it equal to 4, because there's an unlimited amount of things that multiply to be 4, right? 1 and 4, 2 and 2, 8 and a half, so forth, okay? So what we have to do is we have to try to make it look like this standard form. So the first thing I'm going to do is I'm going to distribute this guy. So it's going to be 2x squared minus 7x. But what do I need to do with that 4? Where does he need to be? On the other side, right? So since he's positive, when I move him over, what's he going to change to? Negative. There we have it. You guys see what we did? I kind of did 2 steps in one. I distributed my x to get 2x squared minus 7x, and I moved my 4 over, so I have my ax squared plus bx plus c equals 0. All right, no GCF because 7 ruins it, so my a times c is negative 8. So, what are factors of negative 8 that would get you up to a negative 7? 1 and 8. Which one's negative? The bigger guy, the 8. So we'll write this as 2x squared plus 1x minus 8x minus 4 equals 0. Remember, whenever you come up with your factors, the first term, 2x squared, and the last term, negative 4, always stay the same. And then you just rewrite that middle term, 7x, 1x, and a negative 8x, okay? And then you do factor by grouping. There's no number you can take out of 2 and 1, but what can you take out of it? What do they both share? An x. So that will leave you with what? 2x plus 1. And that's kind of like why I like to leave that there, because if you just leave it as an x, you're tempted to kind of just close it off. But if you write it as a 1x, you factor out the x, and that 1's there. It's like your placeholder. All right, 8x minus 4. Notice that they're both negative, so what are we going to have to factor out? A negative. But what do you want to take out of 8 to be left with a 2, or 4 to be left with a 1? A 4, negative 4, absolutely. And remember, you're dividing when you're doing that. So negative 8 divided by negative 4 is a positive 2. You didn't touch the x. Negative 4 divided by negative 4 is a positive 1. And then you close off your parenthesis and set it equal to 0. Again, celebrate the small things in life. Look what happened, guys. We have that matching 2x plus 1 that's going to come out. And what's going to be left? X minus 4. Does that look all right? After that, you're like sweating because it's kind of a big problem, but you've done the hard work, okay? At this point, if you just set each of your little factors equal to 0 to solve them, okay? So we're going to take 2x plus 1 and equal it to 0, and x minus 4 equal to 0. Because the whole idea is, what number times what number equals 0? Well, we've got to figure out what we can plug into x to make that 0. What can we plug into x to make that 0? On this one, you would have to move the 1 over to get 2x equals negative 1 and divide by 2. So negative 1/2, is that what you guys got on that one? And then x equals positive 4? Yay! And so, real quickly, we can actually check the 4. 2 times 4 is 8. 8 minus 7 is 1. So the parenthesis is 1. But what did we plug in for x? 4. 4 times 1 is 4. Yay! 1/2 is not as easy to check, but if you did it, you did the math correctly. So do you guys notice that we just have kind of extra steps of getting it into the standard form that we're used to seeing, but after that, it is factoring using the AC method and then setting those equal to 0. On this next one, guys, why he's a little bit different is what can we take out of 2, 4, and 30? A 2, and I'm going to take out a negative 2 since my leading term's a negative, okay? So when I factor out a negative 2, guys, it's going to change all the signs, right? So negative 2 was taken away, so now it's positive x squared. Negative 4 divided by negative 2 is a positive 2x. And then a positive 30 divided by a negative 2 is now going to switch to a negative 15 equals 0. So then, what we have to realize is that negative 2 potentially could be part of our answer because it's a factor, but notice that negative 2 does not have an x involved. But we'll bring it down just in case we need to remember, okay? We'll remember to write negative 2 as part of our final answer. Okay. So what we're going to do is the AC method here. My a is 1, my c is negative 15. So my AC, I kind of run out of room, is negative 15 there. So factors of negative 15 that will add up to 2. Factors of 15 that will add up to 2. We'll start with 1. 1 and 15, will that add up to 2? No. Will 2 go into 15? No. So we got to go to 3. What did you say? 5 and 3. Don't you agree, since it's a negative 15, if we finagle the negatives of 5 and 3, we can get 2, right? And it's always the bigger factor will carry the sign, so since it's a positive 2, our 5 will be positive and our 3 will be negative. Does it matter where I put them? Absolutely not. Either way, you're going to be able to factor them, okay? So let's write x squared minus 3x plus 5x minus 15 equals 0. Could you have written it as 5x minus 3x? Absolutely. You'd get the same answer, okay? What can we take out of the first two terms? An x. But what are you going to be left with? X minus 3 on that front one, right? You had the, yes. So you did opposite. You were exactly right. So she had the 5x in front, so she's going to have x plus 5 on hers. I have x minus 3. And then the back half, remember, she's going to want hers to match x plus 5, so she's going to want to take out a negative 3, so it works. We want ours to match x minus 3, so I'm going to take out a positive 5. And you're going to see that we're going to get the same answer. On mine, since I took out a 5, I'm going to have x minus 3 remaining. But that's what I wanted, right? So the final product will be x minus 3, x plus 5. You got that though, Anna, didn't you? Okay. Equals 0. All right. So we now have 3 factors. Negative 2, x minus 3, and x plus 5. Set each of them equal to 0. I know it's like totally running out of room. And solve. Well, that first one, negative 2 equals 0, is there a variable there to even solve for that? No. So anytime you take out a GCF that's strictly a number with no variable, it's not really part of your answer. So this can't really happen, so we're not going to worry about that. Over here, these two guys, they're just linear, which means just move them over using the opposite sign. So do you get positive 3 and negative 5? Does that look okay, guys? And what you can do, again, if you wanted to check them real quick, you plug them in there, you hit enter, you'll get 0. But negative 2 did not have a variable to solve. Now, if that was a negative 2x, your answer would be x equals 0. But since it had no variable, we didn't worry about it. All right, so this one's actually not too hard, but we get tripped up when we see just binomials. Like, oh my God, how do I factor this? Well, what's the number one rule in factoring? Always look for what? A GCF first, right? So what can we take out of 3x cubed 12x? Not only an x, but we can also take out a 3, right? So let's factor a 3x out of this guy first and see what we're left with. Well, we took out the 3 and we took out 1x, so what remains in the first term? Does that look all right? And then what will remain in the second term? A 4. Once you take out your GCF, ask yourself, can you factor what remains? You can. This is what we learned last Monday. This is called the difference of 2 squares, right? So the 3x will remain, but remember when you factor 2 squares, I call it kind of the open arms method, okay? How are we going to factor x squared minus 4? Well, we just say, well, what's the square root of x squared? Who's going to go in front of each of these? X. What's the square root of 4? 2. And then what do I need in order for the middle term to disappear? Opposite signs. Look at that, guys. You factor that bad boy. And I think it's pretty impressive that this really small, concise binomial splits into a pretty massive product, right? It's crazy that if you multiply all that stuff, you get that original one. Okay, so we have 3 factors. 3x needs to be equal to 0. X plus 2 needs to be equal to 0, and x minus 2 needs to be equal to 0. Okay? And notice this one, 3x equals 0, actually has an x to solve, right? How do we solve for x? Well, we need to divide by 3. But if you divide by 3, what's that just going to give you? 0, right? You divide that by 3, that cancels out, x equals 0. This one you just move the 2 over by subtracting, and this one you move the 2 over by adding. But remember what I said in the beginning of today's lesson. Usually the higher power will dictate how many answers you have. So notice this had the cube as a power, and notice how many answers we have? 1, 2, 3. Is that 100% of the time? No, but it's usually a majority of the time. You guys, we're almost done because the back page is like barely anything, okay? So you're doing great. All right, let's look at this bad boy here. Notice it kind of looks like a factor already, right? It's like, oh, it's already factored. So let's set each of our factors equal to 0. So let's set 5x minus 1 equal to 0. And let's set 2x squared plus 15x plus 18 equal to 0. And solve each of these. Well, what do you notice about 5x minus 1? You can solve that, right? That's a linear equation that you can move the 1 over and divide by 5. So we can solve him. So this is just 5x equals 1, x equals 1/5. Is that okay? But then you're like, well, Molly, You told me every time I got it to factored form and I set it equal to 0, I should be able to solve them. We can. But notice this one is not a linear term, it has a square, so this is just kind of like what we've been doing up here, right? So this one factor is just a quadratic that we'll just use the AC method on. Real quickly, look for a GCF. No GCF you can take. So I know we don't have a whole lot of room, but we have 2 times 18 is 36, guys. So we want to think of factors of 36, which is nice. They're all positive. I like when all my factors are positive. Factors of positive 36 that add up to positive 15. So you do 1 and 36, that adds up to 37. 2 and 18, that adds up to 20. 3 and 12, that adds up to 15, okay? So I'm going to rewrite this as 2x squared plus 12x plus 3x plus 18 equals 0. Is that AC method going okay for you guys? Okay, and if not, like I said, just come see me and we'll work a little bit extra practice in there. Remember, it's products that multiply to be that. So what multiplies to be 36 but adds up to the 15? 12 and 3 multiply to be 36, but they add up to 15. All right, real quickly looking at those two terms, what's the GCF of those two terms? 2x, you got it. When you take the 2x out, you're simply dividing. So 2 divided by 2 is gone. You took away one of its x's, so x remains. And then 12 divided by 2 is 6, and you took away its x, so x plus 6 is what remains. Which is perfect, because what can you take out of 3x plus 18 to have an x plus 6 remain? A 3. And how do I tell myself that, guys? I go, okay, I wanted just a single x there. Who's in my way right now? A 3, right? So at this point you have it completely factored because you can take x plus 6 up to the front, and that would leave 2x plus 3 remaining. So you have the second part factored. So don't forget we have this first part factored over here. So 1/5 is one of our answers, so we need to box that in. And then down here, you'll just set each of those equal to 0. So you have x plus 6 equal to 0 gives you x equals negative 6. And then 2x plus 3 equal to 0, you got a little bit more work there, don't you? Move the 3 over to make it negative, and then divide by 2, so you get negative 3/2. Does that look okay? Guys, how do you answer this? Because this is kind of a new thing for my math lab. How you answer an equation with multiple solutions is you just put commas between them. So like this, you do 1/5, comma, negative 6, comma, negative 3/2. And an easy way to do fractions is a backslash bar, okay? So don't feel like you have to do that little, whatever that key code that pops up when you're doing my math lab. All right, are there any questions on that? Again, it's not an obvious cubic, but if we would have taken this 5x times this 2x squared, we would have gotten a 10x cubed. So this whole thing is technically a cubic, so that's why we had 1, 2, 3 answers.
For put it in my math lab, does it have to be in a parentheses and then squared? Or no, can it just be x equals?
You know what? I think they have the x equals. So like, I think they're going to have this, x equals, and then a big box for you to put the answer in. Okay. So you'll do 1/5, comma, negative 6, comma, negative 2/3, like that. Or 3/2. Don't put the wrong answer. Like that. Is that okay? So I think a lot of times they have the x equals, and then you're just putting in the actual x that you found. All right, last one, guys. Honestly, we probably could do this one or not do this one because he is just kind of a version of this guy. Oopsie, over here. It's a GCF that you take out from the beginning, and he's part of your solution, and what remains is a trinomial that we factor. So looking at this, what can we take out from the very beginning? 2. A 2 and an x. Yeah. So we have a 2x. I got it write really small. I didn't leave a whole lot of room, did I? So we have 2x. I think the line leaves it glare. There we go. All right. So the 2x, when we take that out, what's that going to leave us with? X squared minus 2x minus 15 equals 0. Eek! I'm like barely getting them on there. Does that look all right? And I don't know, this like isn't even a really good one because it's basically the one right above it. You guys notice that our AC is negative 15 again. It's just that our 2 symbol flip-flop, right? So we know we had 3 and 5 before, but the 5 was positive. We're going to have 3 and 5 again, but the 5 is going to be negative this time. So 2x is going to be part of my answer. I'm not going to worry about writing them over and over again. I'm going to just rewrite this as x squared minus 5x plus 3x minus 15 equals 0. Is that okay that I went to it real quick? It's just the one right above. The AC is still negative 15. Our b that we need to add up to is still 2. The signs just changed, okay? So I'm going to take out an x to be left with x minus 5. And I'm going to take out a 3 to be left with x minus 5. So I have that x minus 5 matching, okay? So my final answer is 2x times x minus 5 times x plus 3 equals 0. Gosh, can you shove yours in there? Is it fitting? Sorry about that. And it's just like the one in the bottom left corner, guys, where each of them are going to be part of our solution. How does 2x equal 0? When x is 0. How does x minus 5 equal 0? When x is positive 5. How does x plus 3 equal 0? When x is 3. So on your worksheet, since you're like kind of individually doing these already, just feel free to do x equals 0, circle it, x equals 5, circle it. But on my math lab, you don't have to write x, 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 x. They're just going to have x equals, and you'll put 0, comma, 5, comma, 3. Is it a negative 3? One of those negative, though? The 3 is negative? Could that be any smaller? Whew! Is that okay? The two new things in this section is, one, get it in that standard form. Move everything over, set it equal to 0. But then you factor like we've been doing. But the last thing is, don't forget to actually solve, okay? And that's something to kind of keep in mind when you're doing your quiz, because the quizzes are comprehensive. If it says solve, it means there's an equal sign there, and you need to get x equals. But if it just says factors, you just factor. You don't have to solve anything, okay? So the back part, guys, is, okay, Molly, you told us the reason why we need a factor is to be able to solve. Great. But what's the point? Like, what are we learning from this? Well, it actually represents where the graph crosses the line. Do you guys remember in your algebra class that when you solved for x, it was where the line crossed the x-axis? It's the same thing here. It says the graph of a quadratic equation, y equals ax squared plus bx plus c, will always be a parabola, so it's kind of like this arch shape. It says to find the x-intercepts, always plug in y equals 0, okay? So to find x-intercepts, you always plug in y equals 0, because on the x-axis, what is your y value? 0, okay? If you cannot solve your quadratic, guys, if it's a prime quadratic, that means we just didn't cross the x-axis, okay? If you find that you only have one answer, so like on the front, guys, remember this one, how we only had one answer, 7/2? That just means the parabola just touched in one spot. But notice a lot of them had two answers, so that means they're crossing in two spots, all right? So basically, it looks like brand new problems. So if you look at these next two problems, they say find the x-intercepts of the graph. You're like, oh my gosh, a whole new thing? No. Basically, all you do is put 0 in for y and then factor like we've been doing, okay? So x-intercepts just mean y equals 0. X-intercepts just means make y 0 and then solve like normal, okay? So we have 0 equals x squared minus 5x plus 4.
Can you,
switch it?
Yeah.
Yeah. Because we're not really comfortable with the equal sign of being over there, so if we want to write it as x squared minus 5x plus 4 equals 0, that's more than okay, okay? That's what's nice about equal signs, is that they're equal on either side, so it doesn't matter. All right, our AC is a positive 4. So what are factors of positive 4 that would add up to a negative 5? 1 and 4, and they're both negative, okay? So we're going to write this as x squared minus 1x minus 4x plus 4 equals 0. And again, do you have to write that 1x? No, I like to leave it there, so when I factor out that x, it's going to remind me that I need a placeholder, okay? On this, when you factor out the x in front, it just leaves you with x and then minus 1, right? Because we took out the 1x, but we've got to show that it was there. And then back here, we're going to take out a 4, but we want to switch our sign. So we're not going to take out a 4, we're going to take out a what? Negative 4, right? Whenever you want to switch your signs, you factor out that negative. And that will leave you with a minus 1. All right. So we have it where we have the x minus 1 that matches. So x minus 1 will come in front, x minus 4 will be what remains. And what we have found is that we can set each of those equal to 0, okay? So x minus 1 equal to 0 will give you a solution of 1. X minus 4 equals 0 will give you a solution of 4. What's different about the x-intercepts, you're like, okay, there's nothing really new, we had it equal to 0, we solved like normal, is that x-intercepts are an actual point on the graph, and points on graphs are x comma y, right? So on my math lab, they'll say, hey, give me your x-intercepts, but in a point form, in an ordered pair, all right? So what you have to realize is that we have two x values. We don't just make an ordered pair of 1 comma 4, right? We have two x values. One is 1, one is 4. But what was the y value that we plugged in from the very beginning so that we could factor? 0. So what does that mean? It means if we were to plot that parabola up here, guys, like, and I'll show you on our calculator here in a second. If we graph x squared minus 5x plus 4, we know for a fact that that parabola is crossing at 1, 0, and 4, 0. And I can show you that real quickly. I'm going to turn that light back on. And you guys don't have to do this, because we don't actually get into graphing until the very last chapter. But you can actually plot your parabola. So I'm going to write, what was it, x squared minus 5x plus 4. I'm going to graph it. But notice where it crosses, at 1 and 4. Okay, and we were able to solve it algebraically instead of using a graphing calculator. And I'll show you how to do that with a graphing calculator when we get to that chapter. All right, last one, sorry. I know it's long, a couple more minutes. This is another one where they want us to find the x-intercepts. The x-intercepts are just screaming at you, just make y 0. So we can actually write this as 2x squared minus 7x minus 15 equals 0. We'll switch the order for you there so that you feel comfortable with it. 2 times negative 15 gives you an AC of negative 30. So what are factors of negative 30 that add up to negative 7? 1 and 30, 2 and 15, 3 and 10, 5 and 6, 3 and 10, right? So we're going to make 10 the bigger guy in the negative because the 7 is a negative. So we'll write this as 2x squared minus 10x plus 3x minus 15 equals 0. And you still want to do your charts, but if you can kind of run through the factors by yourself in your head, you're more than welcome to do that. All right, 2x squared and 10x, we can take out a 2x, so we'll take out a 2x. When we do that, we're just dividing, right? So 2 divided by 2 is 1. I took away one of the x's, so I have an x. What will remain on the back half? A negative 5. Because I took away its x, and negative 10 divided by 2 is negative 5. Back here, what do I want to take out of those two to be left with x minus 5? A 3. And a positive 3, right? The signs are good, so we'll take out a positive 3, and you'll be left with x minus 5. Woohoo! So x minus 5 will be pulled out in front, and that will leave us with what? 2x plus 3? You're almost there. You just have to set each of those equal to 0 to find the actual solutions for x. X equals 5. Oopsie, I'll set them equal to 0 first. I like to show that step. If you don't, it's okay. X minus 5 equals 0, and 2x plus 3 equals 0. So this will give us a solution of x equals 5. This we'd have to move the 3 over to get a negative 3, and divide by 2 to get a negative 3/2. Is that all right? So then your answer, you might put that in, and they're like, oh no, answer as an ordered pair. Well, remember, you found the x value. So you found 2 ordered pairs, technically. 5, 0 is one of the ordered pairs. And then comma between that one and negative 3/2, 0 is the second order pair. And that's what you'd put into your answer box there.